Well, thank you. How's everyone doing today? Day two. Everyone up, ready, bright and bushy-tailed? Well, I want to thank you all. I know there's a ton of events, ton of sessions you can go to, so I really appreciate you all checking this out. My name is Brett Roberts. I am the Global Partner Technical Manager at Splunk, supporting our relationship, our technical innovation, our roadmap between Splunk and AWS. And I'm here today to talk to you about something I think we're all really excited about, something that's really near and dear to my heart, AI, right? Who's heard of AI before? Yeah, right, everyone's going to raise their hand. It's a pretty common thing right now. But what we're going to talk about today is how you can accelerate your AI journey with Splunk and AWS. So just quick forward-looking statement disclaimer. Nothing here is forward-looking, but everyone's read this by now, so we can go ahead and get started with the presentation. AI is transforming enterprises at an unprecedented rate. That statement right there, I think everyone in this room can agree with, that where we are in the AI journey has transformed and evolved from organizations using AI for pet projects, science projects, one-off initiatives, to actually integrating, incorporating AI into the fabric of the business, the products that they deliver to customers, the services that they offer to customers. And as organizations have done this over probably the last, en masse in the last 18 months or so, they're seeing the immense benefit of how customers can interact with their products, get a better experience, drive more revenue and profit for themselves, be more productive. And so as organizations are doing this, they're increasingly integrating and bringing AI more and more into that operational fabric. But this causes some challenges and risks as we do this, and especially when we think about what are the challenges that bringing AI into mission critical applications that we deliver to our customers, that we provide to our customers. What are those IT challenges? Now, these aren't new challenges. I think IT has really had to deal with these challenges for a very long time now. But when you factor in the complexity, the scale, and really the mission critical nature of AI as we're delivering it to our customers, these challenges are amplified exponentially. And we think about this, the first one is monitoring. When I have an AI application or something that is based on AI, I not only need to monitor the stack, the infrastructure, the application layer, and everything that goes with it, but I also need to monitor how we prompt and how we interact with the AI. Prompts, guardrails, performance, how customers are actually using it, and what they're getting out of it, right, to make sure that it's highly accurate. So it's a whole additional level of monitoring AI within an application. As we evolve and shift to this new forefront of where AI is today, we're at the kind of uncharted waters, which is very dangerous when we think about how do we secure this, right? At the forefront, that's where all the bad actors are, all the hackers are, and we want to make sure on the IT side that we're staying in front of that. So as we're kind of getting into this new era of AI, we also need to look at how do we ensure that we're securing these AI systems ahead of the bad actors that are already out there and already are trying to access it. Because the downside of not being able to secure your AI systems are AI being used for bad customer experiences, loss of revenue from our customers and within our business as well. And then the third one, it goes without saying, is AI requires a ton of data. And in order to be highly predictive and highly accurate, that data needs to be vast and it needs to be broad. And so you need to be able to bring in all this data, store it, maintain it, and then feed that back into the training as well. So monitoring, securing, and data access are all things that IT has dealt with for decades now, but we add that additional wrinkle of AI and the scale of AI that causes it to be highly complex. And so this is where Splunk comes in, and Splunk has been doing this for years now, helping customers secure and monitor their data, but now we've kind of brought this all together with what we call the unified platform for security and observability. And what that means is we're bringing all this together through one view where you can bring all of your data into one platform and use that to drive your security use cases, threat detection, threat hunting, compliance, as well as your observability and monitoring use cases like reducing mean time to resolution or detection, or just monitoring your systems to make sure that they're highly available for your customers. And we're doing this through one platform where you can bring all of your data, whether that's AWS first-party data services that we'll talk about in a few minutes, whether that is third-party data, on-prem data, data from other clouds, all into one unified pane of glass and view to kind of help you both monitor and secure your systems. And we wrap that not only to allow you to do this for AI, but we wrap that with our own AI built in that I'll talk about in an upcoming slide to help you be even more precise and help you really drive that digital resiliency objective. And when we think about AI and Splunk is not new to AI. We've been bringing and probably providing AI systems and tools to our customers for years now. We have the machine learning toolkit, which really allows you to build machine learning models using Splunk's SPL and the data that's already in Splunk. We've woven AI into our IT service intelligence and our monitoring tools, and then also in our enterprise security SIM tools as well. All of these already today have AI baked in for more prescriptive and predictive recommendations. You can onboard a data source and it automatically will start telling you where in those service levels there's issues. So we're not new to the AI game, but as our customers are evolving their use of AI, as AI adoption is evolving, we need to not just be able to provide AI baked into our products, we need to evolve how we provide AI services to you all as well. So what we're doing this in 3 ways at Splunk right now, and the first one is, how do we help you all improve your digital resilience through AI? That's things like offering AI assistants custom made for observability, where you can go in and working with an AI assistant understand where the issue is in the stack and actually in very short time resolve that issue, reducing downtime, increasing profit and customer satisfaction. In security, onboarding data and automatically populating threat detection and then using AI assistants to identify where those detections are. We're helping you bring, Splunk it's been in the data game since its inception. We're helping you leverage all that data to now also customize AI with that data. How do you create your own custom AI models and AI LLMs and FMs using the data that's already in Splunk? So those first 2 are things that we're doing. They're super interesting, but the one I want to really set the stage and talk to you about for the next 10 minutes or so is how are we helping customers secure and monitor their AI applications and AI services. And our goal as Splunk is to be able to do this across the vast landscape of AI that customers are using today, whether that's on-prem, homegrown models, AWS services, or what have you. But since we're at reInvent, what I'm going to focus on today is how we're actually helping you secure and monitor your AWS services. So this is the AWS generative AI stack that you see, and it has everything from all the infrastructure that you use to help build and train and run and inference your AI models. We heard a lot of really cool, exciting releases and future announcements today in the keynote. This is all the infrastructure that's helping drive that. On top of that, you have Amazon Bedrock, where you can build your own Gen AI applications, work with AWS or third-party LLMs and FMs to build these Gen AI applications. And then AWS takes it one step further, and they actually have applications where you can build things like AI assistants using Q Business, or App Studio, where you can actually use AI to accelerate how you build apps. But and then you have SageMaker as well, right, for machine learning and really to help drive that model development. This is AWS's suite to help you all be more successful and to deliver your custom AI services and applications to your customers. But when we start thinking about, now that they're first-party mission-critical services, we need to monitor them, we need to secure them. So what Splunk is doing is we're partnering with AWS to provide insights and visibility into all the different layers in the stack, so specifically with the AI lens and what we want to monitor within AI, what those issues are and where they are. For today, I want to really dive into Bedrock and what we're doing to actually help you bring in Bedrock data into Splunk and then build really cool dashboards that help you gain visibility across a variety of different use cases for IT monitoring, but also for AI monitoring as well. And bringing data into Splunk from AWS is super simple. We do this a number of different ways across logs, metrics, and events and traces today as well, across over 100 different AWS services, from CloudWatch to CloudTrail, Route 53, EC2, EKS, and so on. You can use things like Data Firehose to bring data directly into Splunk with very low latency. You can use a Splunk add-on to kind of pull that data from S3 using SQS, or you can use Lambda functions as well. So there's a variety of different ways today that you can actually bring all of this AWS data and third-party data into Splunk easily without having to build a lot of custom pipelines. But what we just started working with is how do we extend our services that we interact with to those AI tools here, right, that we talked about within the generative AI stack within AWS. So what we did was, and what we started was with how do we do this with Bedrock, right? Bedrock is probably one of the more commonly used AWS services for AI today to build your generative AI applications. And so what we did was, working in the AWS console, we went in and all you have to do is you have to turn on model invocation logging within Bedrock. So we turned that on and we selected CloudWatch and S3 as our logging destinations. And then within CloudWatch, so once we turned on model invocation logging and selected CloudWatch, whenever you ran a job or an invocation, or you were building something within an LLM or FM within Bedrock, those logs and metrics would be sent to CloudWatch. Then within CloudWatch, we wanted to set up a custom log group. In this case, we did one for Bedrock logs, and then we did a separate one for Bedrock metrics. That's all you really have to do to get logs out of Bedrock. Then within Splunk, if you're familiar with how Splunk works, all you have to do is set up a HTTP event collector to go in, you add the token, and you add the endpoint from that HEC into Firehose. You set up a new Firehose stream, and then you add that subscription filter within CloudWatch. So really within 6 steps, you're getting data that's being generated in Bedrock into Splunk using Firehose and CloudWatch. And that data is coming in sub-second response. So as you kick off these invocations, you're getting all that data into Splunk. So when you think about some of the common use cases where you want to identify if there's an issue happening, whether that's performance, whether that is bad behavior, either on the AI side or on the user side, all of that can come at your fingertips in sub-second response time. So this is a graphic of what the data looks like in Splunk. And when Splunk brings it in, it actually automatically goes through the log and pulls out all of these interesting fields and extracted fields, and it gave a wide variety of data that when we started to look at what are the use cases we wanted to provide, we were able to pull things out like what models are being used and what models are being used the most and for what purposes. Many organizations have multiple AWS accounts today, so how are we slicing things up by account and by users within that account? So maybe Brett Roberts is using a ton of models a lot, and he probably shouldn't be using this model for this type of invocation or this type of prompt. What users are doing, what prompts users are making, are they appropriate? Are they following the company guidelines? Again, as you become first-party services, we want to make sure that they adhere to our security and monitoring guidelines. Guardrails is a big thing that AWS provides to ensure that you can do that. How do we monitor if Brett hits a guardrail? How do we bubble that up to the right people to make sure that we're either training Brett on using Bedrock more efficiently and properly, or how do we cut that off before bad behavior happens? Cost in the form of tokens, message detail, error reasons. It's not just guardrails that cause errors, it's max tokens, it's poor prompting. How do we identify all this stuff and then feed that back to the users and to the application so that it's running better and more performant? On the performance side, it's how do we actually talk about latency? What's the latency by model, by user, by account, and by region? You know, is the Claude Sonnet model running better in US West 1 or US in Ohio and US East 2, right? So it's those things that we want to be able to show to the users so they can make more impactful and informed decisions. And then a big thing is cost, right? If we're turning on the spigot or we're allowing more people in our organizations to build AI applications, we want to be mindful of cost sprawl and understand what that cost implication is, and the cost per job, cost per what that prompt is as well. So these are all the things that we kind of identified as what are our common use cases to at least build something out of the box for you all to be able to leverage to get insight into your Bedrock services as well. So I'll just give you a couple examples of dashboards that we've built and kind of what this looks like. This right here is kind of an overview dashboard that provides a kind of an executive overview into the entire Bedrock service within that organization. So you have number of accounts that are using Bedrock, number of users within that account, what region is the most active, right? If right here it's US East 1, but if I don't have an organization that uses London, for example, maybe I want to double click into why are we running jobs in London. So it gives you some of that more descriptive and diagnostic information. Most used model, account, and then most active user as well. Like dropping down to the second line is where you start to get some more of this correlative information, where you can look at how many invocations have been run in the last 24 hours. How does that compare to the day before? If we see a sudden spike where, say we ran 150 invocations, but we normally only run, on average, 61 a day, why the jump? Why the doubling in size? Do we need to investigate what's going on? Is it a code issue, or is someone doing something different within model development? When we think about errors around guardrails and tokens and max tokens, what's the activity over the last 24 hours compared to historical trends? And then cost. How much are we spending on a daily basis compared to the average daily spend? If you start seeing that number spike, again, we can double click very easily with Splunk and being able to correlate and dive into the logs to see why that number is spiking, what the cause is, and how do we resolve that. And then we have additional just views on account activity by time, user activity, and then error reasons by account and by reason. So usage, performance, and cost are really the three categories and pillars that we wanted to start to identify. And there's more out there, and I highly encourage you all to kind of think about what are your use cases and how you could apply getting data into Splunk to building your own dashboards. But within usage, we wanted to look at the invocation stats, total number of jobs being run by model, which models are being used the most, which models are being used the least. If we have an organizational policy not to use a certain model family or type, but then we start seeing that pop up in our dashboards, that causes some alerts or red flags that we would want to double click into. Where is the activity taking place? And where are the failed invocations taking place as well? But you can see here, this gives you an example of a view that someone who wants to monitor how the organization is running AI can definitely get a quick insight into. On the cost side, we want to look at what are the costs of each model from an input token, an output token, and a total cost. So what's the prompt, what's the output from the AI, and what does that cost look like? And every model is different, so we actually have created lookup tables that pulls an API, pulls the latest costs by region, by model, into Splunk. So you can see, if I'm running an AWS model, it's going to cost this much per token, versus if I'm running Meta or Claude or AI2O. And then we want to think about cost is somewhat subjective or relative, because if I'm writing a very complex prompt and the output is very complex, that's going to be a more expensive job. So what we want to do is we want to normalize that so you're seeing it based on the standard. And that's what we were able to do through this dashboard here. And then lastly, performance. How are our models performing? Where is the latency if there is massive latency? How does it compare to average jobs being run? How does it compare to the all-time and not all-time? And then which model is most performant based on prompts and based on region? And what's interesting here, again, you have to normalize this. So if I do a very easy prompt, why is the sky blue? My latency should be very low. But if I do a very long prompt, summarize this meeting or summarize something within my application, that output's going to be a lot longer and that latency is going to be a lot different. So we want to normalize that as well. So again, these are just some ideas. The beauty of this is you can very easily, going back and using those steps, turn on logging in Bedrock, bring that into Splunk using CloudWatch and Firehose, and begin to actually explore the data, explore all the different areas, and start building your own dashboards. So I only have about 45 seconds left. I do want to answer questions, but I'll be over on the side if you do have any questions. But I do just want to leave you with, we're doing a ton of AI stuff outside of just monitoring, like I talked about. We're building custom AI assistants to help you with security, observability. We're building AI into our tools. So if you want to demo or see what we're doing on a wider spectrum within AI, stop by the Splunk booth. We have a bunch of different demos that we can show you there. We have our AI product management team and experts there who work very closely with AWS to build a lot of this. And then we have a few theater presentations in our booth over the next couple days to go deeper into how we're actually doing this with Bedrock and other AWS services. And if you want to see a demo and actually interact with this data, you're more than happy to stop by. We're showing that at the booth as well. So with that being said, I'm going to leave you. I'm running out of time, so I'm just going to be on the other side here to answer any questions. And thank you very much for your time.